Hello, welcome back. Welcome back. I'm John, an old YouTuber and PC gamer. It's a little bit more than 10 p.m. I did watch the news in Danish television and I did download more PDF. I need to update my PDF documents because that's like more than 1 month ago I did download. Like the next one, assembly language, I did find a new one. I need to do that before I'm reading my PDF. I have to check everyone if we have a more new version. I did not do that with this one. But let's close for today. Yes, close the blinds. No, I need to check when I start reading on video. I have to check the PDF if we have a more new version. And I have a folder. Every time I read this PDF, I put in. I have a folder called Finish Reading. So, and if I have a copy, then I add the dates. The date I was reading the PDF, I was adding to every PDF. But then I need to get a fresh copy. I have to get a fresh copy of all PDF I'm already reading. But not everyone, but I'm not read so many. I should do that with Intel CPUs. I think I read about five or six of the Intel CPUs, but I think I'll do it again. I will make new lists. I will download a new copy of list of Intel CPUs. I did download a new version, so I did not forgot that. But this assembly language, this one, I did just download a new one. That was last edit 12 June. That's like yesterday. But this Wikipedia, that's very old, so they have writing on this document many years, so there's nothing super big different. They're not writing everything different. They maybe they add some new information. They're adding some news and edit some wrong one. But we're not going to read that now. We're reading continue the other one. This one read tomorrow. This one are not really needs. I can read on. I have in my. I have it on my web page. I don't need it there, but we have to start from there, and I have charged the camcorder. Yes, I've charged the camcorder like 1 hour. So let's check the sound level. That's 58. I have to close the door to my living room. But I have finished uploading. These 3 videos is public. So let's just continue. I like to finish because I have this long break at 3 weeks. So this is why this PDF that got like 1 month old. They have not been updated a lot more than 1 month. Let's continue, read page by page.
FreeBSD. FreeBSD first added X86-64 support under the name AM64 as an experimental architecture in 5.1 release in June 2003. It was included as a standard distribution architecture as of 5.2 release in January 2004. Since then, FreeBSD has designated it as a Tier 1 platform. The 6.0 release version cleaned up some quirks with running X86 executables under AM64, and most drivers work just as they do in the X86 architecture. Work is currently being done to integrate more fully the X86 application binary interface, ABI, in the same manner as the Linux 32-bit ABI compatibility currently works. NetBSD X86-64 architecture support was first committed to the NetBSD source tree on the 19th of June 2001. As of NetBS 2.0, released on the 9th of December 2004, NetBSD /AM64 is a fully integrated and supported port. 32-bit code is still supported in 64-bit mode, with a NetBS 32 kernel compatibility layer for 32-bit syscalls. The NX bit is used to provide non-executable stack and heap with per-page granularity, segment granularity being used on 32-bit x86. OpenBSD. OpenBSD has supported AMD64 since OpenBSD 3.5, released on the 1st of May 2004. Complete in-tree implementation of AMD64 support was achieved prior to the hardware's initial release because AMD had loaned several machines for the project's hackathon that year. OpenBSD developers have taken to the platform because of its support for the NX bit, which allowed for an easy implementation of the W*X feature. The code for the AMD64 port of OpenBSD also runs on Intel 64 processors, which contains cloned use of AMD64 extensions. But since Intel left out the page table NX bit in early Intel 64 processors, there is now X capability on those Intel CPUs. Later Intel 64 processors added the NX bit under the name XD-bit. Symmetric multiprocessing, SMP, works on OpenBSD's AMD64 port, starting with release 3.6 on November 1, 2004. DOS. It is possible to enter long mode under DOS without a DOS extender, 65. But the user must return to REL mode in order to call BIOS or DOS interrupts. It may also be possible to enter long mode with a DOS extender similar to DOS/4GW, but more complex since X86-64 lacks virtual 8086 mode. DOS itself is not aware of that, and no benefits should be expected unless running DOS in an emulation with an adequate virtualization driver backend. For example, the mash storage interface. Linux. Linux was the first operating system kernel to run the X86-64 architecture in long mode, starting with the 2.4 version in 2001, preceding the hardware's availability. 66-67. Linux also provides backward compatibility for running 32-bit executables. This permits programs to be recompiled into long mode while retaining the use of 32-bit programs. Several Linux distributions currently ship with X86-64 native kernels and userlands. Some, such as Arch Linux, 68, SUSE, Mandriva, and Debian allow users to install a set of 32-bit components and libraries when installing off a 64-bit DVD, thus allowing most existing 32-bit applications to run alongside the 64-bit OS. Other distributions, such as Fedora, Slackware and Ubuntu, area available in one version compiled for a 32-bit architecture and another compiled for a 64-bit architecture. Fedora and Red Hat Enterprise Linux allow concurrent installation of all userland components in both 32 and 64-bit versions on a 64-bit system. X32 ABI, Application Binary Interface, introduced in Linux 3.4, allows programs compiled for the X32 ABI to run in the 64-bit mode of X86-64 while only using 32-bit pointers and data fields. 69, 70, 71. Bautis limits the program to a virtual address space of 4 GB. It also decreases the memory footprint of the program and in some cases can allow it to run faster. 69, 70, 71. 64-bit Linux allows up to 128 TB of virtual address space for individual processes, and can address approximately 64 TB of physical memory, subject to processor and system limitations. 72. macOS. macOS X 10.4.7 and higher versions of macOS X 10.4 run 64-bit command line tools using the POSIs and math libraries on 64-bit Intel-based machines, just as all versions of macOS X 10.4 and 10.5 run them in 64-bit PowerPC machines. No other libraries or frameworks work with 64-bit applications in macOS X 10.4.73. The kernel, and all kernel extensions, are 32-bit only. macOS X 10.5 supports 64-bit GUI applications using Cocoa, Quartz, OpenGL, and X11 on 64-bit Intel-based machines, as well as on 64-bit PowerPC machines. 74. All non-GUI libraries and frameworks also support 64-bit applications on those platforms. The kernel, and all kernel extensions, are 32-bit only. macOS X 10.6 is the first version of macOS that supports a 64-bit kernel. However, not all 64-bit computers can run the 64-bit kernel, and not all 64-bit computers that can run the 64-bit kernel will do so by default. 75. The 64-bit kernel, like the 32-bit kernel, supports 32-bit applications. Both kernels also support 64-bit applications. 32-bit applications have a virtual address space limit of 4 GB under either kernel. 76, 77. The 64-bit kernel does not support 32-bit kernel extensions, and the 32-bit kernel does not support 64-bit kernel extensions. OS X 10.8 includes only the 64-bit kernel, but continues to support 32-bit applications. It does not support 32-bit kernel extensions. However, macOS 10.15 includes only the 64-bit kernel and no longer supports 32-bit applications. This removal of support has presented a problem for WineHQ and the commercial version crossover, as it needs to still be able to run 32-bit Windows applications. The solution, termed Wine32 on 64, was to add thunks that bring CPU in and out of 32-bit compatibility mode in the nominally 64-bit application. 78, 79. macOS uses the universal binary format to package 32 and 64-bit versions of application and library code into a single file. The most appropriate version is automatically selected at load time. In macOS X 10.6, the universal binary format is also used for the kernel and for those kernel extensions that support both 32-bit and 64-bit kernels. Solaris. Solaris 10 and later releases support the X86-64 architecture. For Solaris 10, just as with the Spark architecture, there is only one operating system image, which contains a 32-bit kernel and a 64-bit kernel. This is labeled as the X64/X86 DVD-ROM image. The default behavior is to boot a 64-bit kernel, allowing both 64-bit and existing or new 32-bit executables to be run. A 32-bit kernel can also be manually selected, in which case only 32-bit executables will run. The easinfo command can be used to determine if a system is running a 64-bit kernel. For Solaris 11, only the 64-bit kernel is provided. However, the 64-bit kernel supports both 32 and 64-byte executables, libraries, and system calls. Windows X64 editions of Microsoft Windows Client and Server, Windows XP Professional X64 edition and Windows Server 2003 X64 edition were released in March 2005. 80. Internally they are actually the same build, 5.2.3790.1830 SP1, 81, 82, as they share the same source base and operating system binaries, so even system updates are released in unified packages, much in the manner as Windows 2000 Professional and Server editions for x86. Windows Vista, which also has many different editions, was released in January 2007. Windows 7 was released in July 2009. Windows Server 2008 R2 was sold in only x64 and Titanium editions. Later versions of Windows Server only offer an x64 edition. Versions of Windows for x64 prior to Windows 8.1 and Windows Server 2012 R2 offer the following 8 TB of virtual address space per process, accessible from both user mode and kernel mode, referred to as the user mode address space. An x64 program can use all of this subject to backing store limits on the system, and provided it is linked with the large address-aware option. 83. This is a 4096-fold increase over the default 2 GB user mode virtual address space offered by 32-bit Windows. 84, 85. 8 TB of kernel mode virtual address space for the operating system. 84, as with the user mode address space. This is a 4096-fold increase over 32-bit Windows versions. The increased space primarily benefits the file system cache and kernel mode heaps, non-paged pool and paged pool. Windows only uses a total of 16 TB out of the 256 TB implemented by the processors because early AMD 64 processors lacked a CMP XCHG16 instruction. 86. Under Windows 8.1 and Windows Server 2012 R2, both user mode and kernel mode virtual address space have been extended to 128 TB. 22. These versions of Windows will not install on processors that lack the CMP XCHG16B instruction. The following additional characteristics apply to all x64 versions of Windows: ability to run existing 32-bit applications, .exe programs, and dynamic link libraries, .dlls, using WAL64 if WAL64 is supported on that version. Furthermore, a 32-bit program, if it was linked with the large address-aware option, 83, can use up to 4 GB of virtual address space in 64-bit Windows, instead of the default 2 GB, optional 3 GB with /3 GB boot option and large address-aware link option, offered by 32-bit Windows. 87. Unlike the use of the /3 GB boot option on x86, this does not reduce the kernel mode virtual address space available to the operating system. 32-bit applications can, therefore, benefit from running on x64 Windows even if they are not recompiled for x86-64. Both 32 and 64-bit applications, if not linked with large address aware, are limited to 2 GB of virtual address space. Ability to use up to 128 GB, Windows XP/Vista, 192 GB, Windows 7, 512 GB, Windows 8, 1 TB, Windows Server 2003, 2 TB, Windows Server 2008/Windows 10, 4 TB, Windows Server 2000